Hi, this is Nimla Rednam. In this video, we are going to start the topic squares and square roots, which is the fifth chapter from NCERT textbook, class 8. Now, we are already familiar with the term square. If you remember, in our chapter Understanding Quadrilaterals, we came across this term square, which is nothing but a quadrilateral which is both equiangular and equilateral, right? Now the origin of this word in algebra for numbers is from geometry. Okay, so let's look at the square in our geometry first once quickly. So here I have a square. If the side length is A, then the area is side into side, which is nothing but A square, right? Now here in algebra, basically geometry started several hundred years earlier than algebra. So that is where the concept of square started, right? And in our algebra, when you're looking at numbers, when do you say that a number is a square number? If you can write it as a product of two same numbers, right? N into n equal to n square, then n square is said to be a square number. Another word for square number is perfect square, right? So this is about square number. So if a number can be written as product of two equal numbers, then it is said to be a square number. Or you can also say if a number is multiplied by itself, the result, the product is nothing but a perfect square or a square number, right? So given any number, you can always find the perfect square corresponding to that number. If I ask you what is 2 square, for example, you can always find it as 2 into 2 equal to 4. Similarly, whatever be the number, however big the number, if they ask square of that number, you simply have to multiply the given number with itself and you will get the corresponding perfect square. Now, alternatively, if a number is given to you, okay, and you have to check whether it is a perfect square or not. Now, clearly, whatever be the number, there are only two alternatives. Either it is a perfect square, it is not, or it is not a perfect square, right? So, how do we check whether a given number is a perfect square or not? In order to do this, what we are going to do is first look at the pattern, okay? First find out all the perfect squares, 1 square, 2 square, 3 square, so on, right? Now you will notice that you continue up to 9 square, which is 81, and then 10 square is 100. Now once you go to 11 square, okay, which is 121, you will notice that 12 square is 144. You will notice that the units place is going to be the same. Okay, if the units place here is 2, okay, which is same as the units place for 12, then the units place for the square obtained is going to be the same. Here it is 4 in this case, and for 12 square also it is 4. Now the reason for this is very obvious when you look at the multiplication process itself. For example, when I'm saying 11 into 11, what are we doing? First, I'm going to multiply the units place of this multiplier with this number 1 into 1, 1, right? And then 1 into 1, 1, and then I'm going to take the next tens place digit and proceed further. So this ones place digit, as long as the digit in the ones place is the same, the digit in the product for in the ones place is again going to be the same. That you can see clearly from the multiplication process itself, right? So that means that any perfect square ends with one of these digits, right? Now what are these digits? Let us look at that. If we take in the ascending order, okay, 0, you can see 0 clearly is there. You get 1 sometimes. 2, you can notice that you never get a 2, right? And then look at 3, again you never get a 3. 4 you're getting. 5 is also, coming in some of them. 6 is there, 7 is not there, 8 is not there, and then 9 is present. Okay, so these are the digits that you see in this first 10 perfect squares, and we have already established that it is going to be the same for any number after 10 also, you're going to have a pattern that 1 square ends with 1, then 11 square, 21 square, 31 square, 41 square, any number that ends with 1, the square is also going to end with 1. That we have already established. So these are the digits. So what are the remaining digits left out? You have 2, 3, 7 and 8. Now these 4 digits are clearly the digits with which a perfect number never ends. Okay, so what this means is that whenever a number is given to you and you have to check whether the number is a perfect square or not, if you see that, if you notice that the number ends with one of these 4 digits, then you can immediately conclude that it is not a perfect square. Okay, you can conclude that it's not a perfect square. Now what are you going to do if it ends with one of these 0, 1, 4, 5, 6, 7? Now here what we have established that is that a perfect square ends with one of these numbers, but that does not mean the converse is true. That is, any number that ends with one of these digits is always going to be a perfect square. That is not true. So we cannot immediately conclude that a number ending with 0 is always a perfect square. You can quickly check it with a counter example. Okay, for example, 10 itself is not a perfect square. 20, 30, 40, 50, none of them are perfect squares until you reach 100, which happens to be a perfect square, right? So now let's look at 1, for example. Another, let's give a counter example for that. 11 is not a perfect square. 21 is not a perfect square. 31 is not a perfect square. The first perfect square after 1, the next perfect square is going to be 121 itself. 81, right? After 1, the next perfect square that ends with 1 is going to be 81. Okay, so you can see that if a number ends with 0, 1, 4, 5, 6, 9, I cannot immediately conclude that it is a perfect square. I need to check further. But to rule out that a number is not a perfect square, this method definitely works. That is, if it ends with one of these digits, I can immediately conclude that it is definitely not a perfect square. Okay, I need not check anything further after that. So that is one type of question that can be asked, that they will give a number and ask you to check whether it is a perfect square or not. Another type of question that they can ask is, they will give you some number and they'll say what will be the units digit of the square of this number. For example, it can be a very large number, okay? And they'll ask you what is the units digit of the square of this number. Without knowing the entire number and without actually calculating the square, that is multiplying the number by itself, you can always say that the square is going to end with 6. One's digit is going to be 6 for the square of this number. Okay. Now for this, if you again go back to the observation that we made for the perfect squares from 1 to 10, you will see that any number that ends with 1 and you can say 9, for any number ending with 1 or 9, the perfect square is going to end with 1. Okay, any number ending with 2, the perfect square is going to end with 4. You can check even for 8, the perfect square is going to end with 4. Next, any number that ends with 3, the perfect square is 9. What else? Even for 7, the perfect square is going to end with 9. What about 4? The perfect square is going to end with 6. And even for 6, it's going to end with 6. What about 5? The perfect square is going to end with 5. And finally, when it is 0, the perfect square is going to end with 0. In fact, you need to have even number of zeros here, either 2 or 4 or so on. Here you can add a additional condition that it's the number of zeros, it can't be an odd number of zeros. It has to be an even number of zeros. Okay. So have we covered everything? 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And I've got 0, 1, 4, 5, 6 and 9. So these are the ones digit of the perfect squares of the numbers that are ending with these numbers. Okay. So this is another type of question that can be asked. Now let's quickly look at the try these questions concerning this part of the theory. Okay, let us look at the try these questions. Now here, find the perfect square numbers between 30 and 40. You can clearly see that we've already seen the first 10 perfect squares. 5 square is 25, 6 square is 36, okay, and then 7 square becomes greater than 40. And is there any perfect square between 50 and 60? The answer is no. You can see that 7 square is 49, which is less than 50, and 8 square is 64, which is more than 60. So there is no perfect square between 50 and 60, right? Next, try this question. Can we say whether the following numbers are perfect squares? How do we know? Like we discussed, we have to look at the ones digit. Okay. If the ones digit is 7, I can conclude that it is not a perfect square. We have discussed this. So yes, here it is not a perfect square. If it ends with 3, again I can conclude that it's not a perfect square. If it ends with 8, I can conclude that it is not a perfect square. If it ends with 2, I can conclude that it's not a perfect square, right? If it ends with 9, can we say whether it is a perfect square or not? I cannot say for sure unless I check further. Okay, I need to find the square root, or by trial and error, or by factorization, I need to be able to write this in terms of product of two equal numbers. Okay, I cannot conclude in this case. Even here, when I have 1, there is a possibility that it is a perfect square, but I cannot conclude immediately without any further investigation. Okay, so that is about the this try this question. Okay, there's one more here. Write 5 numbers which you can decide by looking at the units place that they are not perfect squares. That is easy. Any number ending with 2, 3, 7, 8, right? 2, 3, 7 and 8. I can immediately conclude that it's not a perfect square. Write 5 numbers which you cannot decide just by looking at the units place whether they are square numbers or not. Again, here you can give examples of numbers ending with the 0, 1, 4, 5, 6, 9. Okay, any number that ends with one of these digits, there is a possibility, but you cannot decide just by looking at the units place, right? So that is the try this question that they have given. Now here, which of these would end with the digit 1? Clearly this won't end with the digit 1. This won't end. In fact, we can quickly say this ends with digit 9. Okay, 3 square is 9, 7 square is again 49, so ends with 9. 2 square is 4, so ends with 4. This ends with 1 and this also ends with 1. All you need to do is look at the ones digit, find the square of that ones digit, and that is going to be the ones digit of this entire square, however big the number is, right? So next, try this question. This we have already done. If the number ends with so and so, what will be the number in the ones place for the square of that number? That we have already done in detail. Which of the following numbers would have digit 6 at the units place? Okay, so 9 square is ending with 1, so this is not the answer. 4 square is ending with 6, so yes, this one will end with 6. 6 square is again ending with 6, so this will end with 6. This will also end with 6. 4 square is ending with 6, so this one will also end with 6. So 4 out of the 5 numbers that they have given, when you find the square root, you can actually find the square and then check that it is going to end with 6. Okay. Next, what will be the ones digit in the square of the following numbers? So again, you will only look at the ones place, and then 4 square is 16, so this will end with 6. 7 square is 49, so this will end with 9. 8 square is 64, so this will end with 4. Here it's going to end with 0, in fact 2 zeros. Here it's going to end with 4. Here it's going to end with 6, right? So that is the answer for these. Try this question. You need not give the complete square, actually find the square. You simply need the ones place, okay? So that is about this try this question. And here you can see that they're mentioning how if a perfect square is ending with 0, then you need to notice that it always ends with even number of 0. It cannot end with odd number of zeros, okay? Now here, the square of which of the following numbers would be an odd number or an even number, y. So now here again, how do you decide whether a number is even or not? You're always going to look at the units place. However big or small the number is, all you need, all the information you need is the units place. So here, square of this is going to end with 9. So it's an odd number, right? Square of this is going to end with 8 square is 64. So 4. Therefore, this is an even number. Square is an even number. Square of this is going to end with 1. That means it's an odd number. Square of this is going to end with 0, 2 zeros. And so this is an even number, right? So that is how you're going to solve this question. What will be the number of zeros in the square of the following numbers? Now here I have 60 square. I'm going to get 2 zeros. Okay. 1 0 from each 60, you will get 2 zeros. I have 400 square. Here I am going to have 4 zeros. 2 zeros from each number 400. You will have 4 zeros in this case. So here the answer is 2 zeros. Here the answer is 4 zeros, right? So that is about understanding the numbers, whether it is a perfect square or not, how to check, how to rule out, purely based on looking at the units digit. Going further, we will also be looking at how to, find a square root of a perfect number, and different methods like factorization, long division, and so on. But for now, we are only investigating whether the given number is a perfect square or not, purely by observation. Okay. So that is about the first section. In the next video, we will be looking at some interesting patterns that they have given here regarding perfect squares, and try to understand them, try to look at the proof also wherever it is possible. And then going further, we will look at the first exercise 5.1.